Hi students, welcome to the ABK Chemistry channel. See, in the previous video we have discussed about SN2 mechanism of haloalkanes. So in haloalkanes generally the nucleophilic substitution reactions are going on through two mechanisms. Number one is SN1 mechanism, number two is SN2 mechanism. So in the last video we have discussed about SN2 mechanism. Now in this video come to the discussion about SN1 mechanism. Which mechanism? SN1 mechanism. So SN1 is nothing but substitution nucleophilic unimolecular reaction. First observe the reaction what is going on in SN1 mechanism, SN1 reaction. Tertiary butyl chloride, the carbon can be binded with 3 carbon atoms, tertiary carbon, to the tertiary carbon halogen is attached. So it is considered as a tertiary butyl chloride. React with aqueous potassium hydroxide, it will be converted into tertiary butyl alcohol. First reaction, which one is converted into which one? Tertiary butyl chloride is converted into tertiary butyl alcohol. See how the mechanism is going on. Actually the mechanism is two-step mechanism, this one. Why it will be going on in 2 steps is nothing but, see, first you have to take here nucleophile. If for example I am going to taking nucleophile is OH minus here. In the tertiary butyl chloride, in the reactant you have to take, in the tertiary butyl chloride, what is the nucleophile is there? Is the nucleophile there is no chance to attack on the central carbon atom. Why? Because here front side a bigger nucleophile is there and this nucleophile will be carrying which charge? Negative charge. Negative repulsions are going on when the nucleophile will be attacked from front side. On the back side which one are there? Bulky groups are there. Methyl group is one bulky group and this methyl group is also bulky group. This methyl group is also bulky group. Because of presence of 3 bulky groups and 1 nucleophile around the central carbon atom, there is no chance to attack this nucleophile on this carbon atom. So because of this, what will happen is nothing but, first two, what is the halogen, which halogen is directly bonded to tertiary carbon atom, that halogen will be completely detached, completely break down and to form a carbocation. Which carbocation we are getting here? Tertiary carbocation we are getting here, tertiary butyl carbocation. The name of this cation is tertiary butyl carbocation. Now, after breaking off, after complete detachment of this carbon chlorine bond, and there is a space to attack the nucleophile from front side as well as back side. See, in the second step, attacking of nucleophile, which nucleophile? OH minus on carbocation. See here, if the nucleophile will be attacked from front side, what are the 3 methyl groups are? Those will be comes to back side. When the nucleophile will attack from back side, these 3 methyl groups will be goes to front side. See, if nucleophile will be attacked front side, what will happen? And this product we are getting here, and now it is looking same as the reactant. That's why there is no change in its configuration. That's why we are called retention of product. Product configuration, there is no change. If nucleophile will be attacked from back side, for example, and these 3 methyl groups will be goes to front side, and we are getting inversion product. We are getting which one? Inversion. First in reactant 3 methyl groups are present at back side, and now we are getting front side. So this is called inversion product. That means in the case of SN1 mechanism, what is the name of the product is nothing but there is a chance to form retention product as well as inversion product. Retention product to inversion product. There the product name is Walden inversion product name, where SN2 mechanism. In SN1 mechanism, the name of the product is retention product as well as retention. So retention as well as inversion, both we are getting here. Okay, are you understand why the reaction is going on in 2 steps? See, in first step there is no chance to attack nucleophile on the central carbon atom. That's why in first step completely breakdown of CCl bond can take place. In second step there is a chance. Why? Because some space is created after removing of nucleophile. Then it will be there is a chance to attack front side, back side. If front side means retention product, if back side means inversion product we are getting here. Coming to what are the properties of SN2 mechanism, you have to observe here. See, the rate of reaction, rate especially depends on the, if this mechanism is which step mechanism? 2-step mechanism. One step is going on slow step, another step is going on fast step here. One step is going on slow, another step is fast step. Always keep in your mind, students, if the reaction is going on 2 or more steps, such type of reactions are known as complex reactions. In complex reaction, the total speed of reaction, the rate of a reaction depends on the reactants which are participating in slow step. Slow step is known as rate determining step. Slow step is known as rate determining. It will be determines rate. In this step, how many molecules are involving? On that concentration only the rate of reaction depends. So in this last step only the tertiary butyl chloride will be involved. So the rate of reaction depends on only tertiary butyl chloride but not nucleophile. In SN2 mechanism, the rate of reaction depends on both methyl chloride as well as nucleophile. But in the SN1 mechanism, the rate of reaction depends on only tertiary butyl chloride. Keep in mind, that is rate of reaction only depends on them. So because of participating of only one molecule here, the molecularity you have to take in as a 1. And you have to observe here, the concentration of reactants power, what is the value is there? 1 is there. That will be taken as a order. It is a first order kinetics, students. Why? Because sum of the powers of concentration of reactants power, what is the value is there? That value you have to take in as a order. It is a first order kinetics. Now molecularity is 1. Why molecularity is 1? In slow step, how many molecules are involving? Only one molecule is involving. In rate determining step, how many molecules are involving? Only one molecule is involving. Hence it will be considered as a unimolecular reaction. Okay. Now it is a 2-step mechanism. No doubt in it. One is slow step, another one is fast step. Why it will be going on 2 steps already explained. Okay. Now intermediate is carbocation here. Intermediate is a carbocation. In SN2 mechanism, the intermediate is transition state. But here the intermediate is carbocation, students. And next, reactivity order. There first primary, secondary, tertiary is there. Here what is the order? Benzylic, allylic and alkyl. If you take alkyl, tertiary alkyl, secondary alkyl, primary alkyl. This is the order of reactivity of different alkyl halides. If you take alkyl halides, iodides are the more reactive than bromides. Bromides are more reactive than chlorides. Chlorides are more reactive than fluorides. Okay. The same order is going on in the case of SN2 also. In SN1, SN2, this step is common. Iodides are the more reactive than bromides. Next chlorides. Least reactivity is fluorides. Okay. Rearrangement will take place. Rearrangement. Why rearrangement will take place? For example, the carbocation is present 2 degree. If there is a chance in the molecule to get a tertiary carbocation, then the rearrangement takes place. If for example 3 degree is there, compared to 3 degree allylic more stable, compared to allylic benzylic is more stable. For example, if 3 degree is there, there is a chance to get benzylic, immediately rearrangement can take place. Okay, keep in mind, students, rearrangement can take place. But in SN2 mechanism, there is no rearrangement. Now, see here, polar protic solvents, they are non-polar solvents. Where? SN2 mechanism. In SN1 mechanism, polar solvents like water, alcohol, like which one are polar solvents are there? The polar solvents are favorable for this condition, for this mechanism. Okay, so like that. And SN1 mechanism is, these are the properties of which mechanism? SN1 mechanism. And this is how the mechanism can take place. Okay, like that. Very, very important. Maximum information will be present here. See, in the case of here, see what is the carbocation we are getting, students, here? Carbocation. This carbocation is a planar. The carbocation is a planar. Here the carbon is present in sp2 hybridization. The trigonal planar, it is a planar molecule. It is a trigonal planar molecule. Structure is trigonal planar. The carbon is present in sp2 hybridization. Okay, like that. And these are the maximum information regarding which mechanism? SN1 mechanism. So thank you for watching this video, students. Please subscribe and like the channel and activate the notification bell icon for further updates. Thank you so much.